Now we take this problem 56 of the questions. It says that two balls having masses m and 2m. Let us say this is the mass m and this is the mass 2m. Are fastened to two light strings, as shown in the figure, of same length x, right? The other ends of the strings are fixed at O. So this is a fixed point. That means the two strings are tied at this point. The strings are kept at the same horizontal line and the system is released from rest. If it is released, obviously there will be a collision. How there will be a collision? Both of them will come to this point. Some point of time, there will be a collision here. Let us say, let me draw the situation just before collision. Just before collision, say this is 2m and say this is m. This is just before collision. This is m. And just before collision, the velocity, of course, will be horizontal. The velocity will be horizontal. This velocity, say this is u, and this velocity also will be u. Why? Because both of them are falling from the same height. From the theories of chapter of kinematics, that u is, that u, say u is the velocities just before collision, just before collision under root 2 gx, because this height is x. This height is x. Anything, any mass doesn't depend upon the mass. Any mass falling from a height of x will have a velocity of under root 2 gx. And since, and the problem given here, the velocity of mass 2m will be horizontal towards left and velocity of mass m will be horizontal to the right. Right? And let us draw a diagram after the collision. Let us draw a diagram after the collision. After the collision, what happens? After the collision, this will be moved towards right immediately after the collision. And this velocity is, this is mass 2m and this is mass m. This will move towards left. Say this is v1. This will happen immediately after the collision. So we can use the theory of conservation of momentum from the principle of conservation of momentum. The principle of conservation of momentum, what we can write, that mass m, which is before the collision, mass m, and let us say this is x-axis, which is positive x-axis, right? So the velocity of mass m is in the positive x-axis. So we can write mu, but velocity of mass 2m is in negative x-axis, minus 2mu. It has the same velocity u is equal to mv1, mv1, but v1 is in negative direction, plus 2mv2, because from here, if we cancel all the m's, what we find? We find that from here we find u minus 2u is equal to v1 plus 2v. What we get? 1 plus 2v equal to minus, sorry, this v1 was negative v. I am very sorry. Minus v1. So this equation will be a little different. So what we have is v1, if we take v1 on the left hand side, v1 minus 2 is equal to, and u will become the right hand side, is equal to u. Say this is relation 1. Now we go to the principle of the relative motions, relative velocities. Since it's a perfectly elastic collision, so we can write here, since it is an elastic collision, the relative velocity of approach velocity of separation. What is the relative velocity of approach? Here, just looking at the picture, you can find relative velocity of approach is 2u, and the relative velocity of separation is v1 plus v. So 2u is 1 plus another relation we have got. Another relation. So from these two, we can find out the values of v1 and v2. So what do you do? Relation 1, we go to relation 1. It was v1 minus 2v2. 1 minus 2v2. And to this, we add, it's like this, relation 1 plus 2 multiplied by relation 2. This gives you v1 minus 2v2 plus V1 plus 2V2 U plus 4E. From here, 2V2 gets cancelled. So we have 3V1 is equal to 5U. And what is the value of U? U is L. So from here we get V1 is equal to 5 under root by 3. This is one relation we have got. So now from relation 1, relation 1 was V1 minus V1. V1 we have already got. And V1 is 5 by 3 under root GL minus 2V2 equal to U is under root 2GL. From here we get 5 by 3 root 2 GL minus only root 2 GL. This is equal to 2 by 3. This is equal to 2 by 3 into root 2 GL. This is equal to 2 by 3 into there you get V2 is equal to GL by 3. So got the values of V1. This was the answer wanted. And V2. What will be the velocities of these bodies after the find the velocities of the balls just after the collision. There is a second part. How high will the balls reach after the collision? You have already guessed that is not a difficult part. So these balls will start moving upward like this. And this ball also will start moving upward like this because they are tied to the strings. And finding this height is not very difficult because from the kinematics formula, we can always find out the heights, right? And from the kinematics formula, suppose, let us write it like this. Suppose 2m body is height of H2. Suppose the 2m body reaches the height of H2. Then potential energy at H2 is, so mass in G into H2 will be equal to its initial kinetic energy, half mass 2m and V2 square. And V2 square is, so this, again, this 2 and this 2 gets cancelled. So this is equal to mV2 square. And V2 square is 2L by 9, 2GL by 9. Now 2mgh2 is equal to 2GL by 9. So from here we can find, so H2 is equal to M gets cancelled, 2 gets cancelled. So H2 is equal to, not L. Actually, in this particular problem, we have taken this as X, where we have written L. So let's continue with root 2 GL, and this one as L, this one as L, this one also L. The X and L got interchanged. So H2 is equal to L by 9. Similarly, we can find H1. We can find H1. Say M1, M body reaches the height of H1. If M body reaches the height of H1, then in the similar equation, so H1, so MGH1 is equal to half M V1 square, equal to half M V1 is 5 root 2 GL, etc., etc. So this is equal to 25 into 2L by 9. 25 into 2 GL by 9. In this equation, this G and G gets cancelled, M and M gets cancelled, 2 and this 2 also gets cancelled. So what we are left with is, so H1 is equal to 5L by 9. Now, what is 25L by 9? 25 by 9 is actually 2.7 up, almost equal to 2.8 L. That means that value of H1 is much more than L. But the point is, the body is tied to a string of length L. If the body is tied to a string of length L, the body is tied to a string of length L, then in any case, suppose this is a string and this was the length L, this was the body, and it flies upward, and in any case, it cannot go above the length L. Cannot go above the length L because it is tied to a string. So the smaller body will reach a height of L only, since it is tied to a string of length L. It's tied to a string of length L. So answer, one is 12, another is L by 9. Now, Here the solution of the problem ends, but one question you may ask, what will happen to this body edge, the smaller body? Actually, even when it reaches that point, the highest point, it will still have some kinetic energy left with it. So it will continue moving like in this direction with the radius L. And after some time, this motion will drop when all its kinetic energy is exhausted. So this was the problem. Now we shall go to the next problem now.